Okay, so hello everyone, and some of you were complaining that about the Pythagoras thingamajigger there, that like the formula sort of on the Cartesian plane, that it made no sense. It made no sense. No one can teach this. It's stupid. Anyway, quite a few of you wanted me to make another video about it due to the obvious brilliant success of my last video. So yeah, here it is. Hope it helps. Anyway, so I have my beautifully drawn Cartesian plane right here. This is extremely awesome. But anyway, we have these are all 1, by the way. We have the point 3, 2, which would be right there. And we'll even put it in brackets. 3, 2. Shut up. Those are brackets. Then we have 1, 2, 3, 4, 5, 6, 7, and 6. 1, 2, 3, 4, 5, 6. Sorry, I was just touching the screen there. So, 7. No! God! Dang! 7, 6. And for those of you saying, oh, the last program that you used was a lot better, you know what? Shut up. I'm still crying over the fact that I lost that free trial. And then we're going to have last one, which is 4. We have... Really? Are you dumb? Oh, no, this had better not make me have to stop my video. I'm going to have to kill someone if I have to stop my... There we go. Yum. Anyway, 6, 7, 8. We're going to have 4, 8. So right there. And that there is point 4. I don't like this program. I'm just saying that outright. 4, no, not 2. 8. And these are all connected. But I'm just going to draw a beautiful line. Boom. Boom. And boom. Now let's say we want to find the perimeter of this triangle. And obviously using Pythagoras. So basically what you have to do is, look, consider each of these sides, consider them to be part of their own mini triangle. And their own mini right angle triangle. And the right angle is where the two lines intersect, like here. No! Draw, damn it. If I drew an imaginary line here, shut up, it's a beautiful drawing. And here, intersect there at 3, 8. And here you see our beautiful right angle. Kaboom. Now, using Pythagoras, of course, in this mini triangle, we can figure out what this length is because we know what these two lengths are. And for those of you saying, no, we don't, you're so stupid. First of all, shut up. Second of all, we do know how long these sides are. Because the distance, I swear, I am going to kill this program. I mean, I was on a roll. Whatever. Anyway, we know the distance here because of these. These are each, let's say, 1. These are each 1. So we know that the distance from here to... Wow, that was a failed arrow. I'm just going to delete it. From distance from this point here to this point here is however many it takes up here, which in this case is 1, 2, 3, 4, 5, 6. So this here is 6 long. Then we have this one, and we just use the bottom, and it is exactly 1. So this length is 1. And using Pythagoras, we say that the square of 6, which is, and I'll even bring on the on-screen calculator for this, the square root of 6, which is 36, I believe. 6 times 6 equals 36. And then we have, the other one was 1. So 1 times 1 is 1. 36 times 1 is 36. So that means that, let me just get my drawing application back. First of all, screw off. Okay. So we know that this 6 times 6 is 36. 1 times 1 is 1. Which means that this is equal to the square of this is equal to 36. So we take square root of that, and we find out that this is equal to 6. Yeah, that's equal to 6. Okay. So, now we go on here and we do the same thing. We make our imaginary line. And it intersects right there to make a right angle. Right there. That's where we see our right angle. Now, if we know, as I've said before, we know what these sides are. Because here we go 1, 2, because that's how long this one is. It goes 1, 2. So we know that this is 2 long. And this one here goes 1, 2, 3. So it's 3, this one. So the square of 3. Oh, actually, I am so sorry. Some of you are probably just saying now, you're such an idiot. And you know what? Right there, I was such an idiot. You for once, you may call me an idiot. Don't overreact though, because for some reason I was saying the square of this times the square of this is equal to the square of this, but I'm wrong. It's a very rare occurrence, guys. Very rare occurrence that I'm wrong. Relish in it now. But basically, it's this plus this. So 36 plus 1. This is actually 37. And I'll just check quickly on my calculator on my iPad. And the square root of 37. No, clear. 37 square root rounds to 6.08. So I was wrong. This is actually 6, dang it, 0.08. Yes, there's a decimal there. Shut up. There's supposed to be a decimal there. 6.08. That's an 8. Frickin' program. Anyway, that's 6.08. So now we do the same here. As we already saw, this is 2, this is 3. Square root of 3 is 9. Square root of 2 is 4. 9 plus 4 is 13. Square root of 13 is 3.61. So we know now this is 3.61. Now finally we move to the last one. And we do the same thing with the imaginary lines. We have our right angle right here. And this one here is 1, 2, 3, 4 long. And this one here is 1, 2, 3. I swear I'm going to fucking kill this thing. I'm going to kill this thing. I'm going to kill it. I'm going to destroy it till it's dead. Okay, so this here is 4, and this one goes 1, 2, 3, 4. So this one is also 4. So 4 times 4 is 16. 4 times 4 is 16 is 32. Square root of 32 is 5.66. Now, some of you are probably saying, yeah, another one we don't understand is the, that's a 6, I'm sorry. Another one we don't understand is the one where you have a triangle in the box. Well, looky here. Exact same thing. One of the ways you know if you're doing it right is if your imaginary lines, per se, are forming a box around the triangle. So now, of course, we add it up. We have not 2 on my stupid calculator. We have 5.66 over here, plus 3.61 over there, plus 6.08 over there. Yeah? Okay. And the perimeter equals the perimeter equals 15.35. And have a nice life.